Okay, Andy. Good morning, everyone. Online friends, can you hear my voice? Say yes or no to me once. So the last class we worked on anonymous inner class as a implementation class of one interface. We worked it. Yesterday one diagram came and anybody tried this? Raise your hands. Anybody? Right. Okay. Today's class we are working with lambdas. So which is replacement of your anonymous inner class. Anonymous inner class as implementation class model is modified as lambda expression in Java 8 version. The process of declaring method without method name is known as lambda expression or anonymous method. The syntax. And we are writing lambda expression like this. Now observe it. To explain this, one small program here. Example program I am taking one interface. Project application LAMPDA lambda expression 1 I am taking. Here I am taking two packages, package P1 and package P2 I am taking. Package P1 and package P2 I am taking. Under P1 I am taking one interface I am taking. I'll take iTest one interface. I will take it. I'm taking one interface. In this interface, I'm taking one abstract method. I'm taking void m1 of int x. I'm taking. I'll take one default method. I will take it. Void m2 of int y, one default method. So this is one default method. Default method I am taking. The value y is equal to plus y. Here I'll take one interface. I will take, not interface, one static final int a is equal to 10. I'm taking one variable. I'm taking. So system dot out dot println the value a means interface variable a. It can print it. This method can access this one. Okay, right. So I took one interface. The interface. This is one interface. I test. Already name is there, no? Anyway. For this, implementation needed. So whenever you want implementation, for the subtract method, you can write lambda. For the subtract method, you can write lambda. How you'll write lambda means, see the syntax here, sir. Right. Now this is here interface name means I'll take I test. I'll take parameter list means this one. We are providing the body for whom now? Int X. So this body is for abstract method. This is lambda. This is the way of writing lambda expression. This is lambda expression. All of you understood this? This is the way of writing. That will I written here. Lambda expression is attached with the abstract method signature of interface, and we call lambda expression for execution using abstract method name. Okay, right? Anyway, this is lambda. Now this lambda we are going to write under one class. Access. From yesterday onwards, we are taking one class access. No, inside this access, public I test get reference. Inside this lambda will come. This lambda we are writing inside. This lambda will be here. Then return, return OB. Return OB. So this lambda we are going to write inside. Have you understood this statement? We are going to write inside return OB. So this OB is object again. OB variable by the type interface. Interface comes under non-primitive data type. Non-primitive data type variable will hold reference. So definitely object must be created. Okay, right. So I am taking one access class. I am taking under P1. I'll take one class. Under P1, I'll take one class. Class name is access. Like yesterday, access. Inside this, public static method, no, static I test get reference. Inside this lambda, I test OB equal to int X lambda expression. This one. Now here system dot out dot println. The answer is coming from LAMBDA lambda expression. The answer is coming. We are printing X. System dot out dot println the value. The value x is equal to plus x. All of you understood this, right? Here, return return, return OB. So point. So finally, we return implementation class as lambda expression. Implementation class as lambda, lambda expression. This is the syntax. Now the lambda expression is inside. Now inside this, I'll take one variable. So public int b is equal to 20. I'm taking 20. Now I'll print this. So system dot out dot println the value b is equal to plus b. It is printing b or not now, right? When it is print b now, here cannot make a static reference to non-static field. So the concept is, sir, if any this one local to get reference. Now get reference method is static method. So this is inside the static method. So this variable must be static. The variable must be static. Then only it can access. All of you understood this point, right? Okay. Now inside this method, I'll take one more variable. Local variable int c is equal to 30. One local variable I am accessing. System dot out dot println. So the value c is equal to plus c. It is accessing the local variable or not now? Have you observed this? Right. Okay. Now this body is there, no? This body attached with this M1 method anyway. So M1 method belongs to iTest, no? Right. Now M1 is trying to access A. One variable available in the interface or not now? It is trying to access A. So try to access A. System dot out dot println the value A is equal to plus A. See, the error is coming. Here, A cannot be resolved to a variable. It cannot be detected. It is not detecting. So I'll use class interface name iTest.A. I'll access. I'll give a notes. Don't worry what I'm writing. So here the visibility. So finally, implementation class as lambda expression. Lambda expression means what now? Constructing the body for abstract method of interface. Constructing body for abstract method of interface. We are constructing. Now go to the main class. Like yesterday, go to the main class. Under P2, here, demo, lambda, lambda expression 1. So import p1 dot star. Here directly here I test OB is equal to access dot get reference OB dot M1. I'm calling M1. This is lambda lambda expression call. We are calling the lambda expression or not now? So OB dot M2. Sir, this is default method call. Default method call. We'll get the answer. So now I must explain it. What happened internally? Okay, right. So here new keyword not there. Implementation class name not there. Method name also not available. Only body is available. If you look into this syntax, only body is available here. One interface is there. That interface we declared one implementation, but here class name not there. Implementation class name not there. M1 any method name not there. Only body is available here. But here one object is creating for you. One object is creating that I should reveal to you. Okay, right. So today's program, I took P1 itest.java. Under P1 access.java. Under P2 demo lambda lambda expression 1.java, the main class. So this is the program. Now let me explain this program with a diagram. How the object is created. Let me explain. Then I'll get a clarity. Okay, right. Execution flow of above program. Program here demonstrating lambda expression. Demonstrating lambda lambda expression. Right. First class files here. How many class files will come, sir? I want to know. How many class files will come? I want to know. See there. The first class file is itest.class file. Second class file is access.class file. Third class file is demo lambda lambda expression 1.class file. This is main class. So your important point is for lambda expression dot class file will not come. For lambda expression dot class file will not come. And moreover, lambda expression is not a class. It is a method. For method dot class file will not come, no? Right. If it is a class dot class file will come. So anonymous inner classes means dot class files will come. Lambda expression means dot class file will not come. That is the first advantage of your lambda expression. Separate dot class file is not available. That is the 8th feature. Separate dot class file is not available. Dot class file will not come. Only 3 will come. One is interface, one is subclass, one is main class. Now observe the object creation. What is happening here? It is a new thing, and it's a new thing. Okay, right. Now, sir, I took one project here. I took one project. Project name is application lambda lambda expression 1. Here, class files will come. These are compiled codes anyway. And after many diagrams, you know, main class will go for execution, you know already. Main class will go for execution. Main class execution starts. Method area where classes are loaded. heap area where objects are created, Java stack area where methods are executed. So method area, heap area, Java stack area. So main class will be loaded. Main class, main method will come for execution. Main class, main method will come for execution. So this is main method. So anyway, execution engines will come. Right. In this main class, iTestOB is equal to access.getReference. iTestOB is equal to access.getReference. Right. Access.getReference means like yesterday, access class must be loaded. Like yesterday, access class must be loaded. Access class is loaded. Now, in this access class, one variable is there. Can you see this? Static variable is there. Static variable b is equal to 20. 1. Static method is there. One static method. Return type is iTest. iTest get reference. One method. So the variable and method got the memory within the class. Now, once method got the memory now, this method is coming for execution. Like yesterday, get reference method will come for execution. Get reference method is coming for execution. Right? Okay. Now this is iTest get reference. Because their object is coming now, I'm drawing down. This is 1. The method came. Now inside this get reference method, here one local variable is there, no? Right. One local variable is there. This local variable C is equal to 30. One local variable is there. This local variable. Now, Here one lambda is there. Can you see this? Sorry. One syntax is there here. Now, here I test OB equal to I test OB equal to int x 1 lambda. This is the lambda. This is lambda. Now, this is lambda. This is lambda expression available here. Now, by seeing this syntax, I test OB is equal to lambda. It's a new syntax. New keyword also not available here. By seeing that the body not removed, body available there only. Okay, right. The body. So whenever I test OB is equal to this lambda expression, one object is created in the background. New algorithm from Java 8 version. I said one statement yesterday. From 8 version onwards, your language changed. Whenever it sees a lambda expression, here, I test will be loaded. I test will be loaded. I test. I am writing this. I test interface will be loaded. When the interface is loading now, here one variable, static variable. Where A is equal to 10. If you see, A, B, C are in different locations. Have you observed that point? Right. They are in different locations. They are available. Okay, right. Now, here one M1 method is there. So, void M1 of int x. This is abstract. Looking for body. This is default concrete anyway. So, void M2 of int y. So one is abstract method, one is default method. One is abstract and one is default. One is abstract and one is default. Default. Now, once interface loading completed, object creation starts. This is object creation starts. While object creation, this will come. Void M1 of the first method. Void M1 of int x. This method will come. According to interface, when the abstract method comes, it look for the body. That's the rule. It look for the body in the implementation, actually. Sir, implementation class not there. If implementation class not available, it look for lambda. Lambda is there, no? Right. So, our visual is the lambda body is taken. Our lambda body is taken. It's a new thing. Lambda body. There is our visual. Int x is taken. So it became a complete method now. Lambda became one complete method. So it became one complete method here. Now the body is taken from there. Now after this one, remaining method. Remaining method means default method. Void m2 of int y. So this will come. Like this. Now this address whatever the address. This address will be loaded here. One minute. This is your Lambda view. This is. So we are referring with the object. The Lambda referred with the object. Whether body attached or not, the body will be here only, but to hit the psychology of a student, actually it will not come and link there, but to hit the psychology of a student, we say that it is attached, we say. So after this one, here, we are running under access, no? Right. One object created or not now? From today, Lambda means object. Lambda means object. So return OB. Here, return. Return OB. RETURN. Return OB. This address, what is available here? Loaded here or not now? Yes or no? Na? Loaded here. Is a visual. Fluffy got this point? Right. Here one specialty is there. Why they'll ask 8 features means algorithms changed. Today, for that interface method, one body is coming. For interface method, one body is coming from here. The body is not coming from the class. So implementation class not there. Body you declared in inside one more method. That body is attached. That is a visual. But whenever it is attached, that must be an object form. Whether it is object or not, student will get a doubt because I took a default method. Default method available in the object only, no. That is a proof. There is one object available. Now, it returns one address here. Okay, right. This frame will not be destroyed. Lambda expression declared method frame will not be destroyed. Remember the statement. That will be there. Until the Lambda expression executed, that is available. That frame, that algorithm says that don't destroy Lambda expression declared method frame must not be destroyed. It will not be destroyed. The frame will be there. Why that frame is available means Into this frame, lambda expression will come. For execution, it will come. So this is one separate frame or not now, according to your visual. So now I am calling this, see there. OB.M1 I will call. What I'll call now? OB.M1 I am calling. So OB.M1. Remember, Java 8 version different. I said already. Who worked on Java 5? He can work on 6. He can work on 7. Who worked on 5, 6, 7? He cannot work on Java 8. He has to learn it. Totally, many people ask, sir, Java 8 features available, they'll say. Again, you have to learn the language, no other choice. Not only history says. So, JDK 1.0, 1.1, 1.2, 1.3, 1.4. The engineer who worked up to JDK 1.4, again you have to learn Java 5. Because language changed. Who worked up to JDK 7, again to learn Java 8. Because language changed. That's a concept. Because the market will ask for 8 features, they'll ask. All students will come, or your brothers or sisters, they'll say, lambda expressions are 8 features available or not. You ask the trainer, they'll say. So while they'll ask 8 features means, again you are learning the language again. So new things has been happened. What is the new thing here? Sir, new operator not there. New keyword not there here. Here new keyword not there, object is coming. Yes or no? That is the object. Sir, how can you say object? OB is holding address. How can you say OB is holding address? OB declared by the type ITest. What is ITest? Interface. What is interface? Non-primitive. Non-primitive data type variable must hold reference only. It cannot hold value. In that way, object is created in the background. The concept. New keyword not there, but object is created. Generally, the method frames will be destroyed, but in the Java 8 version, the lambda expression holding method frame remains without destroying until the lambda expression comes. Now I am calling lambda. OB.M1 I am calling lambda expression call or not now? OB.M1 I said now. Here. We call lambda expression for execution using abstract method name. We are calling. Here abstract method is M1. So we are calling with M1. OB.M1 we are calling. OB.M1 of 121 we are calling. Sir, we are calling a method. We are calling one lambda. We are calling. We are calling a lambda. Whenever we call a lambda here, lambda will come. This lambda expression will come. The lambda expression came with the method void M1. It came with the method what now? Void M1 int x. It came. Now, what is the diagram means? Lambda expression is executed local to get reference. Already method frame is there for get reference, no? Within that get reference frame only, lambda will come. Lambda expression is executed local to get reference. I've understood the statement, right? Local to. It is executing. Algorithm says that the frame is there. Means actually they will not be in the order. It's algorithmic forms, no? To hit the psychology of a student, we draw some all diagrams and go. one partition created to load get reference. That partition you don't destroy it because lambda expression will come. In that same frame only you should execute lambda. In that same frame only you should execute lambda. The frame can be expanded. No, frame means a small partition only. You have to execute it. Now lambda expression is running local to get reference. Now inside this, what is available in the lambda? Sir, printing X, printing A, printing B, printing C is there. Okay. Now see. Inside this, system.out println X. System.out println I test dot A. So system.out println B. System.out println C, like this. Now this lambda expression is running local to get reference. Now this X is available here only, no, local variable. So the X is loaded with 121. So the X is loaded with 121. You passed 121 as parameter, 121. So the 121 is a local variable. Inside that lambda frame, X will come. Came or not now, right? So X value is coming out. So X value will come out. X is equal to 121. Now it is printing A. Directly A it cannot print. Why it cannot print A directly means, see there. Suppose it want to print A directly. Suppose I test not there. It want to print A. Error will come. Why means this M1 method means not M1 method. This lambda expression running local to get reference. So it look for A in the lambda, not available. It look in the get reference, not available. That get reference method came from where now? Object. Yes or no? Na? So it is available in this, not available. All of you understood the statement, right? Okay. But it will not go to the interface. Sir, why it will not go to the interface means this interface, this body belongs to method only. This body belongs to method only. So this method, example, this get reference method came from where now? Here, no? Sorry. It will not go to object. Sorry. This get reference method came from where now? Class. Yes or no? Na? Right. I'll repeat once. Lambda expression belongs to get reference. Get reference belongs to class. Now look in the lambda expression, not available. Look in the get reference, not available. Then look in the access class, you have to look at it. Because method came from access class. It will not. So it says that I cannot find A and error will come. If you remove this, error cannot be resolved to a variable. A cannot be detected as a variable. So it cannot access. Right. Now it cannot access A directly. It has to access with the interface name only. It can access. Now, it can access B. How it access B now? See, this lambda expression belong to ITest. Sorry, get reference. Get reference belongs to the class. It can access the B or not now. So that is a proof to say that lambda expression is running local to it. If not, how it is coming to access? Moreover, until the lambda expression execution, the frame is not destroyed because into the same frame only lambda expression is coming. It is accessing B. How it is accessing C now? C. Sir, it can access the C directly or not? No, because lambda expression belongs to get reference only, it can access. It is accessing C. So lambda expression can access variables belongs to the method where it is declared. Can access variables belongs to the class where it is declared, but cannot access variables belongs to one interface. It cannot access. Right. All of you understood lambda expression execution? Says or no to me. Lambda expression is running local to the method where it is declared. There's a new thing happened in 8. The lambda expression is running local to one method. Right. This is today morning also. So I am showing that always morning class I am showing to you always. Morning means 7:15 class. Today, I drawn one diagram today morning. This is the diagram. You can see lambda. Can you see the lambda there? Right. I attached with one method or not now? The method coming from here. This is accept method linked with lambda. This is application. Today, component introduction, that is application. This is data structure. Data structure chapter is running by 7:15 batch. The data structure retrieval process, that is. I said no, for your for loop, that is. For each is nothing but your for loop. For loop modified as one method. For Java purpose. Java 8 version this is. Today, the students who came by 7:15, they not understood means they missed classes in core Java. I am running one chapter now, anonymous in our class. That chapter, if a student misses, he will not understand anything. The student who is sitting in 7:15 today, he not understood the class. Who missed your anonymous in our class? If he is not understanding today 7:15, today 11 AM I am writing a project. 11 AM Advanced Java, today project is going to be started. Advanced Java, he will not understand the project. Because today I am dumping the data from database table to server. I am dumping today, 11 AM. So the student who sits in anonymous in our class, if he understands the model, he practices data structure, then he can do one project. That much of link is there. But student feels that core Java is like other language, you must not feel and link is there. C language, C++ different. If you miss 4 or 5 classes also, you can by heart write one examination, pass and come. Because C language is not carrier. C language to pass examination only. But Java is carrier. So every class component is important. Whatever I'm saying today, whatever the points I'm giving to you, it is important. Yesterday, time is there, but I left the class. Yesterday, I given a time to practice anonymous in our class. What you observe now? Sir, if I take anonymous in our class yesterday, dot class file came. Same anonymous in our class today, I took lambda expression, dot class file not there. Dot class file not there means what is the advantage now? Loading time not there. Linking time not there. Loading linking time has been decreased. Automatically performance increases. Not only lambda. Not only difference between anonymous and lambda. If you use lambda, loading time not there, linking time not there. Because separate dot class file not loaded. Automatically, high performance will come with the lambda expressions. Not only 8 feature. Why I shown this means you have to concentrate on this model. Since yesterday onwards, I am showing that model to you. Today, it is running local. Right. Hope you understood. I think. Whenever I want to call default method, you know already. So ob.m to default method. Why I took default method today means to educate that there is one object available. I educated it to you. It's a diagram. Right. The diagram I'll paste here. Okay. From this diagram, I observe. So you have been observed 1 or 2 points today. The frame meaning, whenever you see this diagram, the lambda expression is running local to the method where it has been declared. What is a proof? The lambda expression is accessing C variable. It is accessing C variable. It is accessing B variable also. Means what? It is accessing the method. It is accessing the class. It is not accessing the interface because interface given a method name only, not body. Interface given only method name, not body. Body given by the get reference because access available to get reference. Many people are facing problem who don't have a concept here. They'll write lambda. Above they'll take one variable. Sir, access not coming, sir, the student will ask us. Access not coming means student should know where it is running. Concept not there means that kind of question only will come for it. They'll write lambda in the program. They'll take one variable above. They'll say not coming, sir. You must know that variable permission is available or not. You must locate it. Where the variable available, where the method has been declared lambda. Lambda running to one method. The method has that permission or not. You have to check it. Then only you can resolve that to error. Make it. Note. NOT note. All of you can take one long breath because models over. Core Java, models over. From now onwards, conclusions only. So, models has been completed. Lambda expression is the last model from Java 8. After Java 8, lambda expression not modified. And one more process available based on lambda expression, method reference. With that, your models will be ended. Note here. LAMBDA. Lambda expression is executed local. Local to the method where it is declared. Local to the method where it is declared. Lambda expression is executed local to the method where it is declared. Where it is declared. LAMBDA. Lambda expression cannot access variables of interface directly. Interface directly. Which means access with interface name. Access with interface name. You have to, the 2 points enough. Running local and it has to access the interface variable with interface name. Doesn't it? Right. Coding rules. coding rules of LAMBDA, lambda expression. Some rules we have to take care. Right. In this example, we took one interface. No, what is the interface name now? iTest. So the interface must be functional interface. This interface must be functional interface. That's a rule. Right. Nothing but SAM interface. A single abstract method interface. Functional interface. Right. Make it rule 1. Rule 1. Right. Look here. The interface which provide abstract method to hold lambda expression must be functional interface. The interface which provide abstract method to hold LAMBDA lambda expression must be functional interface, which means single abstract method interface. A single abstract method interface. So you must take only one abstract method you have to take. In bracket. Other than abstract method, you can take any number of concrete methods. No restriction. Other than abstract method, we can take any number of concrete methods. Any number of concrete methods. Other than abstract method, you can take concrete methods, no problem, but only one abstract method you have to take it. You have to take only one abstract method you have to take it. Suppose if I take one more abstract method here, example, I am taking abstract void display. If I take it, here error is coming or not now? The target type of expression must be functional interface. Functional interface means you must take only one abstract method. Other than abstract method, you can take concrete methods. Actually, the other given concrete method for functional interface. Whenever you want to write lambda expression, you need one abstract method. I cannot write more abstract methods. Then the other given permission for concrete methods. So other things you can write it as concrete is it. The reason. So only one abstract method. We call it as functional interface, right? Rule 2. Look here. Whatever the lambda expression here some variable is there, no, x. I must not take c here. Y means already c is here. Now how can you take c, it says? Because both are running local only now. So same thing you have to take. You must not take. Lambda expressions parameter c cannot redeclare another local variable defined in an enclosing scope. Means the scope means where that lambda expression is available. Within that method, you cannot take same parameter names. So meaning, rule 2 you have to follow. Rule 2. The parameter names used in LAMBDA lambda expression, the parameter names used in lambda expression, the same names must not be used for declaring local variables. The parameter names used in lambda expression, the same names must not be used for declaring local variables within the same method scope. Within the same method scope means where lambda expression is declared there. The same names you must not use. You must use different names. Why means lambda expression also expression only, is not a method. So same names you must not use. Any error comes, you must not use. Here already variable name, same parameter name, you cannot use it. So you must use different names. The point. Okay. These two rules, actually this is not a rule, but many people are facing errors. We are writing this rule. Actually, this is actual rule. Only one rule you have to maintain, but all people will come with errors. Sir, why, sir? They'll ask. No, we write that rule and give it. Now, advantage of LAMBDA lambda expressions. Advantage of lambda expressions. Right. What is the major advantage means? When we use lambda expressions, separate class files are not generated. And loading and linking time of execution process is saved. If dot class file is there, it has to be loaded. Yesterday I drawn one diagram to you. Yes or no? Na? Yesterday, lambda expression, not lambda, anonymous inner class, I drawn it. Inner classes. Yesterday, what is the topic? Anonymous, huh? For me, short-time memory loss will be there. I cannot remember the names. Look here. Here, separate dot class file is there, no? Right. Today's program, this only. But if you write anonymous inner class, what happened now? Sir, here it should be loaded. Loaded, linked. Linked means you have to keep in the position. Loading and linking. This is loading and linking. If you use lambda, this concept not there. This dot class file will not be there. That's a major advantage. Make it. When we use LAMBDA, lambda expressions, then separate class files are not generated. When we use lambda expressions, then separate class files are not generated. And loading and linking time is saved. Part of execution process and generate high performance of an application. When we use lambda expressions, then separate class files are not generated. And loading and linking time is saved. Part of execution process. Loading and linking time is saved. Part of execution time and generate high performance. Nowadays, I am starting your class bit late, observed or not now, because morning 7 a.m. batch coming to ending within a week. Data searchers, they are not understanding what I'm saying, because I'm spending more time because releasing that batch, because project is running 11 a.m. for them. So I'm concentrating on them for 1 week only. After that, I'll come back. Why means the people will not be regular. The drawback of students is they will not be regular. Core Java also, they feels like another language but core Java different. So students should be committed and regular. Then only core Java will come. Because of this reason, many people will say core Java very hard, they'll say. It is not hard. The student is irregular. The student actually irregular. 3 months a student cannot come regularly. Moreover, 3 months he cannot read one subject. That much of patience student will not have. But the patience needed. For you, inspiration means group 1, group 2 people are there, no? Their aims for years they'll read. For you, 3 months and they are years and years. One time missed means again 2 years they'll sit. Now government changed, but still they are holding that aim. That's called patience. That patience, 20% you keep also become a good code writer. That patience not there, because Java is very hard. Student point of view only, that point. Regularity will not be there. That problem I am facing in morning 7 a.m. Holidays came, no, Dasra. They came, they celebrated all festivals and they came yesterday. 1 week back they came, I think. Now what happens now? Malayalam movie without title is running. Sir, what happening? They'll be looking and they'll be doing like this and they'll be looking seriously and they're going out. Choice not there. Because project running in 11 a.m. Because of 2 festivals, he neglected. He is not understanding collection framework. He will not understand servlet. He will not understand Spring. He will not understand web service. Total 5 minutes, horrible only for him. That's called link. Horrible. That 2 festivals after getting a job, he might have celebrated. Because of the 20 or 15 days, now he will be facing a problem. Advanced Java, he will not understand. When he go to Spring and Spring Boot, he will not understand. Web service, he will not understand. If any trainer starts one project, he will not understand. Without understanding only, he enters into the market. Daily, he read 100 questions, daily trial. Job not coming, sir. Job not coming, sir. Job not coming, sir. First, you have to check it, whether you are correctly reading or not. Why the job will not come? So, you see how much link is available for the models. Because we trainers are playing a key roles. Small models, what we are drawing, they are very important to you. Now, advantage here, see there, execution process. Execution process is equal to loading, linking, and execution. 3 times will be there. Loading time plus linking time plus execution time. Morning batch I am running here. Around 7:20-25 I will come. I'll give my bag to them. I'll wait outside. Loading time is 7:20-25. But in between, linking time is there. My loader should come and connect it, on it, net it. It has to come. It takes 5 to 6 minutes. It takes for them. So loading time, I'm coming here. Linking time, connecting. Then I must start my execution. Understood this point or not now? For you. Loading already there. Linking already there. Understood this point or now? In between, I am loading, I think. I'll eat 10 minutes. I'll take my breakfast in front of you. I'll go now. Then I'll come again here, 10 minutes, I'll come. So here loading time not there. Linking time not there. At least class is starting around 9:20 roughly, 9:25 nowadays. Right? So 9:20 I can start it. If here also loading time is there, linking, if they change the block, what happened? Example, I used to run to that block and come. Again, what happened now? Loading time included, linking time included, execution time also will be there. Same in your program also, loading, linking, execution. Dot class file not there means loading not there, linking not there, only execution is there. Automatically high performance will come. That is the advantage of lambda expression. All of you got it? Right. Now, sir, yesterday anonymous in our class is there. Today lambda expression is there. Which one I should wear? Which one I should use where? Doubt will come or not now? Write it. FAQ. What is the difference between normal interface, functional interface, marker interface? Normal interface, functional interface, and marker interface. Normal interface, functional interface, and marker interface. The interface which is declared with more number of abstract methods. More number of abstract methods is known as normal interface. The interface which is declared with more number of abstract methods is known as a normal interface. Normal interface can hold any number of abstract methods. Normal interface means declared with any number of abstract methods. The best examples for normal interfaces is, I'll take 2 always. Collection 1 interface, map 1 interface. The diagram what I shown from 7:15 batches, that is map only. So map is an example of normal interface. Functional interface. The interface which is declared with only one abstract method. Only one abstract method is known as functional interface. The interface which is declared with only one abstract method is known as functional interface. Nothing but SAM interface. Single abstract method interface. Functional interface is Java 8 actually. Introduction done in Java 8 version. Examples of interface, functional interface is predicate, by predicate, consumer, by consumer, so consumer, by consumer. Function, 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 by function. These are all 8 features. So by function. This KV, they are all generic types. Marker interface. The interface which is declared with 0 methods. The interface which is declared with 0 methods is known as marker interface. Which means empty interfaces are known as marker interfaces, you can say. Example for marker is serializable, one interface, clonable, one more interface. These two are marker interfaces. They do not have any members. 0 will be there. Clonable. These two are empty interfaces. So interfaces in your Java categorized into how many types now? 3 types. What are they? Normal interfaces will be there. Functional interfaces will be there. Marker interfaces. Marker means no methods, 0. See there, you can see marker interfaces available to you. Java.io.serializable is a marker. No methods. Java.lang.clonable. So clonable is an empty. They do not have any members. That's called marker. If we declare only one abstract method, you can declare any number of concrete method. That is functional interface, the term introduced by Java 8 version. And the six interfaces I given, they're all 8 features interfaces. All are available in your notes, means material. And there I written K, V, T, U, R. That all will be introduced before array chapter, not now. Just they are generic forms. Their notes is available in the array chapter for you. Okay, right. First one is normal interface. Daily you are working, no? Normal interface. Normal interface means any number of abstract methods you can take, no restriction. That is known as normal. All of you got it right. Tomorrow, read that model once and come. Tomorrow, I'll make a revision on it and I'll give an information where to use Lambda, where to use anonymous. I'll write one more program based on Lambda for repetition, one assignment. Tomorrow, we are concluding Lambda expression. We are concluding tomorrow. And tomorrow, we are trying to conclude anonymous local inner classes. Anonymous inner class also, we are going to conclude it. That's a plan, right? Take a break for today. Thank you very much. So yesterday's notes updated, correctly updated, or any name problem? Right. Right. Okay. Thank you very much. You can take a break. So plan yourself by 5:30 advanced Java. I given a suggestion to you so that you can save the time. 5:30 or management is starting on advanced Java. Try to plan it. Okay, right. Sir, management. Information. Sir, again, check this. Static easy access చేయొచ్చు నాన్ స్టాటిక్ ఆబ్జెక్ట్ కొంచెం కాంప్లికేషన్ జీరో మెథడ్స్ రాయొచ్చు కావాలని